Calibration is the process of finding a relationship between two quantities that are unknown. When one of quantity is known, which is made or set with one device, another measurement is made a similar way as possible with the first device using a second device.The measurable quantities may differ in two devices which are equivalent. The device with the known or assigned correctness is called the standard. The second device is the unit under test instrument, or any of several other names for the device being calibrated. The words calibrate and calibration entered the English language as recent as the American Civil War, in descriptions of artillery. Some of the earliest known systems of measurement and calibration seem to have been created between the ancient civilizations of Egypt, Mesopotamia and the Indus Valley, with excavations revealing the use of angular gradations for construction. The term calibration was likely first associated with the precise division of linear distance and angles using a dividing engine, and the measurement of gravitational mass using a weighing scale. These two forms of measurement alone, and their direct derivatives, supported nearly all commerce and technology development from the earliest civilizations until about AD 1800. Early measurement devices were direct, i.e. they had the same units as the quantity being measured. Examples include length using a yardstick, and mass using a weighing scale. At the beginning of the 12th century, during the reign of Henry I, it was decreed that a yard be the distance from the tip of the king's nose to the end of his outstretched thumb. However, it wasn't until the reign of Richard I that we find documented evidence. Other standardization attempts followed, such as the Magna Carta for liquid measures, until the Ma-Diarrhea des archives from France, and the establishment of the metric system. One of the earliest pressure measurement devices was the mercury barometer, credited to Torricelli, which read atmospheric pressure using mercury. Soon after, hydrostatic manometers were designed, with a linear calibration for measuring lower pressures ranges. The Industrial Revolution saw widespread use of indirect measuring devices, in which the quantity being measured was derived functionally based on direct measurements of dependent quantities. During this time, scientists discovered the energy stored in compressed steam and other gases, leading to the development of gauges more practical than hydrostatic manometers at measuring higher pressures. One such invention was Eugene Bourdon's indirect design Bourdon tube. Indirect reading design showing a Bourdon tube from the front and the rear. In the direct reading hydrostatic manometer design on the left, an unknown applied pressure part pushes the liquid down the right side of the manometer U-tube, while a length scale next to the tube measures the pressure, reference to the other, open end of the manometer on the left side of the U-tube. The resulting height difference h is a direct measurement of the pressure, or vacuum with respect to atmospheric pressure. The absence of pressure or vacuum would make h equals 0. The self-applied calibration would only require the length scale to be set to 0 at that same point. This direct measurement of pressure as a height difference depends on both the density of the manometer fluid and a calibrated means of measuring the height difference. In a Bourdon tube, applied pressure entering from the bottom on the silver barbed pipe tries to straighten a curved tube, moving the free end of the tube, that is mechanically connected to the pointer. This is indirect measurement, that depends on calibration, to read pressure or vacuum correctly. No self-calibration is possible, but generally the zero pressure state is correctable by the user, as shown below. Even in recent times, direct measurement is used to increase confidence in the validity of the measurements.